So next what we're going to be covering is section 5.28, which is going to consider the classical index, as we've already defined, and the abstract index that we were just talking about. The main claim of this section is that these two notions are in fact equivalent, and what we mean by that is, formally, is that there exists an isomorphism alpha, which makes this diagram commute, this diagram here. And what this is going to give us is that Z is isomorphic to lambda as a group, and the two functions, the homomorphisms that generate them, preserve the same structures. So what we're going to be looking at in this section is a basic outline of how to construct this alpha. So the first thing that we're going to do is we're going to show that the fn's, which are equal to the inverse images of the jn's, are in fact connected. And the reason for this is because lambda is again a quotient group that's constructed after we mod out the invertible elements by their connected components. So we want to show that these two groups are actually talking about the same things within f of h. So once we've done that, we're going to note that since I is continuous and lambda is discrete, I must be constant on each of the fn's because they're connected components, and hence we need to have that their inverse images under I are in fact open, which can only happen when I is constant. And what this gives us is that alpha of n is equal to it, that if I define alpha of n by it, this is going to be well defined for all t in a given f sub n. Also, since alpha, when we define it this way, since alpha is onto, this immediately gives us that I is onto. What we would then have left to show is that this alpha is in fact a homomorphism, and that alpha is 1-to-1. And the 1-to-1 part we're going to tackle by showing that the kernel of I is in fact F0. So showing that the only elements that map to the identity are going to be those in the connected component of with the identity. So with the multiplicative identity. So what's going to follow all of this is that once we show that this alpha is a isomorphism, that makes the diagram commute, we get three immediate corollaries on J. The first being that it is in fact a multiplicative operator, that it's a multiplicative homomorphism, that it's continuous as a function, and that it's invariant under compact perturbation. So using the rest of my presentations are going to be proofs centered around building up this theory that we need to construct this alpha. So I'm going to let this video end there, and we're going to start up with our first proof on 5.29.